Howdy. So, to finish off for today, I want to talk about crashing databases a little bit. For those of you who use Postgres, you know Postgres is a lot like an elephant. It's very hard to pull over. Tends to be very strong, tends to be very steady. Your sort of normal things of piling load on it don't generally make it fall over. But what I say when I see something like this is that people are simply using the wrong tools. If you want to knock something over, you need to use the right tools. Fortunately, thousands of PostgreSQL users have discovered the right tools on their own. So what I'm going to talk about are not necessarily the 7 cleverest ways to crash Postgres, but the 7 most popular ways to crash Postgres. Number 1, because all it requires is inattention, is don't apply updates. It's our most popular way. Let me explain and give you a little formula here. First, ignore all of those pesky update announcements we send out in our mailing lists. Better yet, don't subscribe to any of those mailing lists, or any of the downstream vendor updates either. Second, keep running on version whatever .0 or .1 pretty much forever. Third, just wait. Sooner or later, something will happen. And by the way, what I mean by updates is it's that last number in your Postgres version number that's sort of a patch number that says where you are in terms of the update of the major version, which is the other 2 digits. And if you're running on less than whatever the current one is, you're missing stuff. As a matter of fact, you're all going to be a little bit late because next week, 923, and release another set of updates on Thursday, I believe. And you get usual bunch of stuff in your Postgres updates with all kinds of other stuff. But here's a couple of fun ones from recent updates. So this is a fun one from 922 where basically if the system was really, really busy and you couldn't get a pipe from the underlying system, not only would that individual child process fail, but it would take the whole server down with it. Not so much fun, and if you didn't update to 922, you're still vulnerable for that. Here's another one, actually, 916. So we've got a lot of people out there. Oh, I'm on 9.1. I'm on 9.11. Well, you're missing a lot of stuff, including this really fun one, where if you decide to change your database to running in serializable mode, and you attempt to restart it on Windows, it won't. We find these things all the time. It's a big, complicated project. There's a million lines of code. We find them, we fix them relatively quickly, but that doesn't do any good if you don't apply the updates. So, if you want to crash Postgres, make sure you're running .0. Oh, also, there's another fun thing. That's an update. There's also upgrades. So another fun thing that you can do is Postgres goes end of life after 5 years. We stop releasing updates for various versions. So, to ensure maximum crashability, you want to be using something 8.3 or earlier, because we're no longer even updating those. Second most popular way to crash Postgres, out of disk space. Postgres is remarkably grumpy about running out of disk space. I don't know why. It really doesn't like it. If you run out of disk space, well, let me give you another formula here. First, and I can't tell you the number of clients I've had that have done this, install Postgres on a disk that's like 80% full. Right? Hey, we've got a couple hundred megabytes free on the disk. We can run Postgres. Next, don't monitor. Or, as more popular, monitor but then ignore the alerts. And then third, let the database grow. This gives you some fun error messages when Postgres suddenly discovers that it can't write to the file system anymore. And not only will Postgres shut down, any attempt that you make to restart Postgres, it will refuse to start back up. Because you're out of disk space. Can't do anything. We're a disk database. Can't do anything. We can't write to the disk. Now that we have built-in binary replication, we have a more advanced technique for running out of disk space. Out of disk space archiving edition. So, for high availability data reliability, we allow you to archive off your database transactions, new blocks of data, to other systems. This provides lots of additional opportunities for running out of disk space. So, here's a recipe again. First of all, I set up a transaction log archiving to a standby system or to a storage system where you're archiving off of your old version of your database. Second, allow the file consumption or deletion on this standby to break and stop operating. And again, don't monitor. This leads to a really fun chain of events, especially if the secondary system was your failover replica. First, what happens is the disk on the standby fills up with archive logs, at which point the standby shuts down because it can no longer write to the disk. At that point, the master, which is saving the archive logs for the standby, will fill up its disk, and it will shut down. And then the automated failover kicks in. This is lots of fun and can lead to a really interesting long weekend. The other fun thing about that I love about out-of-disk space as a way to crash Postgres is that freeing most of your methods for freeing up disk space, your non-destructive methods for freeing up disk space, unless you can delete other things that happen to be occupying portions of the file system or expand the capacity of the file system itself, most of these things require space in order to do their work. Like, vacuum full and reindex will shrink your database, deleting, large numbers of old rows and that sort of thing is called PG reorg. These things will actually shrink your database. So you can maybe get it operational enough to move it to another system or whatever. But the problem is that while they're doing the shrinking, they require additional disk space to hold temporary files, which means they won't operate if you're down to your last 10 megabytes. As a matter of fact, the only things you can do inside Postgres to free up disk space that don't require significant amounts of extra disk space in order to run are deleting things. Which then leads me to the next technique for crashing Postgres, deleting stuff. Specifically the wrong stuff. So you've run out of disk space on Postgres. Oh my God, we have to free it up, or we're down here. I'm getting paged by Nagios every 5 minutes, and therefore I need to start Postgres up again. Well, let's look at, almost 90% of disk space is that Postgres directory, right? So let's look at what's in the Postgres directory. Well, hey, I have these 3 directories that are something log. I bet there's stuff there I could delete. Now, this one usually has lots of stuff in it. So that's, could be a couple of gigabytes, and so you can delete a bunch of stuff there. But, for good measure, let's empty out all of these directories. They're obviously logs. They'll get regenerated. They're OK. This is fun. Because particularly, we have now moved from a recoverable crash condition, being out of disk space, to an unrecoverable crash condition. For those of you who are not familiar, this directory clog, that's the master transaction record for the database. If you delete that, you might as well have deleted the rest of the database. So you get these sorts of errors at this point. At this point, you're going to be hiring somebody. You're either going to be restoring from backup, hopefully, if you have a backup. Or if you don't have a valid backup, then I would hire someone like me and take out a large business loan. So, now, less popular, but getting more popular thanks to the cloud, is out of memory. It's another way to crash Postgres. There's a couple of different formulas for this. One of them is, frequently this crash is discovered by people who are used to administering Oracle. So first, you set shared buffers to like 80% of RAM. This is Postgres' dedicated RAM. So instead of following the general directions, you go ahead and set it to most of RAM. Then you follow it up. There's a setting called work mem, which is how much memory a query can use. Now, work memory is non-shared. It's used, each individual process can allocate this much work memory. And under some circumstances, it can allocate several times this much work memory. So let's set that to 1 gigabyte. Or if I have a lot of RAM, I could set it to 2 or 4 gigabytes. That would be even more fun. And now let's ramp the database up to about 1,000 connections. So that's one popular recipe. The second popular recipe that I've seen with a lot of places is, we're going to go ahead and put Postgres in a cloud server. And that cloud server seems to be holding up well and that sort of thing. And I want to have all of my servers have sort of exact system. So I'm also going to add a JVM to that machine and give that a couple gigabytes of memory. And Apache and mod PHP for the administration system. Oh, and now we've got this PHP widget on there that needs MySQL, so we're in MySQL as well. Oh, and we're getting ready for an upgrade, so let's launch a second version of Postgres on the same machine. Oh, and in either case, I've actually skipped a step 0 here, which is we need to run Linux with the default memory management settings out of the box. Particularly, we need to make sure that OOM killer is on, because everybody loves the OOM killer. So then you can get this, which is a really fun crash. You know, we start out with the OOM killer kills some random Postgres process. But after all, the formula for the OOM killer is explained by Jeff Davis. Step number 1, kill Postgres. Step number 2, check what was actually using memory, and then kill something else. So this will crash, and the fun thing is, if you restart everything, you don't change any of your settings, you can do it again. Now, that's a recoverable crash. So we're going to get back to unrecoverable crashes, namely bad hardware. This is a very popular way to crash Postgres. So first, let's buy some brand new hardware. Particularly, let's buy some of the more affordable brand new hardware. So, you know, the Dell storage system that they've got on special, or this sort of white box thing, or whatever they're promoting. Or, even better, some cutting edge new hardware. Then, let's install PostgreSQL. Don't test anything. Let's just put it straight into production. After all, it's coming from a reputable vendor. Or we used another one of these before. What could go wrong? That's the most popular method of bad hardware. There's a second recipe. We've got 2 recipes. This is a very good one here. One is, you go ahead and test it and you deploy your production hardware, but then let's not do any smart monitoring error or any sort of cohesive monitoring of syslog or whatever, and let's just run the system for a couple of years. Either way, what you get looks like this. And one of the lovely things is, if what went bad was a RAID card or your RAM, then you're probably not recovering anything at all, because you've got a whole bunch of garbage on disk. If you've lost sort of individual disks, individual disk sectors, you can generally recover a portion of your data. This is a fun way to crash Postgres. Now, what?
You don't know when it went bad.
And you don't know when it went bad. We are, by the way, working on some improvements in Postgres detecting bad hardware. And we'll see. Some of those might get into 9.3 or 9.4 because it is a common circumstance, and if you have enough hardware, you're running Postgres in 200 servers, you're going to have hardware going bad constantly. And so Postgres needs to help with that. We're working on it. So, 2 other methods. Now, these other 2 methods are interesting in that neither of them actually crashes Postgres, they just make it unresponsive. But from a system administrator's standpoint, particularly if you've got an uptime guarantee, there's almost no difference from your perspective. Particularly the set of actions you're going to take is often going to be very similar. So the first most popular one is too many connections. So here's our recipe. This is popular particularly in shops where the developers get to call the shots and everything. So number 1, we're going to design this application so that it uses ad hoc connections to the database whenever it wants to make an individual request. Second, we're going to we don't want any connection pooling. No PG bouncer, no JV, J2E connection pooling, no Zeus, no nothing else. And then what we want to do is we want to program the application framework so that anytime it times out because it can't make a connection, its response to that is to try to make another connection. And then let's raise max connections in Postgres up to something like 2,000. Because we might need 2,000 connections, right? Linux is no problem, having 2,000 concurrent processes. So, and then you get these fun pages. Server Postgres is no longer accepting connections, and you look and you say, oh wow, what do you know? I've got 2,000 Postgres processes, and if you do this right, you can hit the out of RAM crash at the same time. Now, the next one's a little bit more subtle. So our 7th one is sort of an advanced technique. And this is what I call zombie locks. So here's our formula. Number 1, we program an application so it forgets to actually close transactions. Now, the most common way to do this is bad error handling routines. You hit an error in the application and it exits without ever having terminated the database session. However, I've seen other popular things. I was just talking to somebody at lunch. I had a recent client who was new to relational databases, and so the way they programmed their application was when a user logged in and at their office in the morning, it opened a transaction. And it committed when they logged out at 5 p.m. So then let's run it for a few hours or days, and we can watch the locks pile up. And then you can get fun errors from the application log because, of course, the database is taking connections, but you can't execute any queries because at this point, all of the data in your database is locked. Also, you get lots of fun database bloating that way. So let's go over our 7 methods again. No updates, out of disk space, deleting stuff, out of RAM, bad hardware, too many connections, zombie locks. If you practice these methods, you can make sure you can lower your uptime from 5 nines to 4 nines or 3 nines, 1 9, 7.5. And avoid having to do any other work. And we have killed our elephant. Now, there's some more Postgres stuff this week. This is finished with more Postgres stuff. Putting together a pizza boff for Wednesday night over in the B&G Rec Room. For any of you, anybody here from Melbourne? So if you're going back to Melbourne after LCA, we're holding a full-day Postgres event on Monday in Melbourne at the Experian headquarters. There's a link there. Or just look up PG Day Melbourne. PGCon in Ottawa, and then you can contact me. So, and that's it for our sysadmin for the day. I'm glad to take questions, but we should probably take questions like on our way to beer. So thank you very much.